Hello, everyone. Okay, let's go. And we're going to talk about caching and the new cache system in Symfony. So Fabian told you that we're using it quite extensively in Symfony 2.2. So, so very quickly, I'm Nicolas Grekas. I'm working at Sensio Labs. I'm as CTO for Blackfire. I'm also a core team member, and I maintain the cache components. So if you have any question, I can sure try to answer after the talk. First, PSR6. So who knows about the PHP-FIG? Okay, good. About PSR6? Okay, so we're going to dive into that. So the PHP-FIG is a group of PHP developers and PHP framework authors and library authors that writes PHP standard recommendations, which are documents that state how to do logging, auto-loading, and things like that. So that's the list of current pull requests. There's some missing in the bottom because I think now we're at 16 or 17. So the first one is PSR0, and PSR0 is the PSR that enabled Composer and auto-loading and this way of putting files on the file system and loading them. They did also a few others, so PSR about coding style, 1.2 about logging, so monologue, PSR3 and things like that. So today we're going to talk about PSR6, and we do care about the PHP-FIG and PSR because having a standard is really amazing and a good way to share implementation and decouple things and say, okay, I follow this contract. And so if anyone else follows the same contract, you can swap implementation and use whatever you'd like to. So the PHP-FIG is something also that gathers individuals, people. It's complicated there to talk together. Everyone has not the same goals. So I used to have a slide there talking about PHP-FIG weaknesses. Yet right now, PHP-FIG is reinventing itself, and we call that PHP-3. So wish the best to PHP-3 so that only the best remains in PHP and PHP makes itself better. So PSR6. PSR6 is about caching, and PSR6, the caching topic in the PHP-FIG, started as a draft in 2013. And then the official version, voted one, was released 1 year ago. This means that it's been quite long to create and to agree on how this should work and how you could do that and how implementers should implement that. So, some goals on the documentation and on the metadata document of the PSR. So, PSR has a goal which is, covering common needs and basic needs for caching, intermediate levels, mid-range system caches, application caches. Another one is to allow, of course, different implementation and extensions so that the PHP can start with PSR6 implementation and build new features which are not yet in PHP-FIG, in any PSR, but are possible. The non-goals, this is also something written on the PSR6 document. They did not want to create something compatible with existing implementation. They wanted to do something with the goal, but not with this goal of following what people already did at that time for caching. And they also decided to not add advanced features for namespacing, tagging, and things like that. So they just wanted to cover basic needs. And this is what we're going to see in the first slides. So before PSR6, and we have, and we will still have Doctrine cache. So Doctrine cache is the major caching implementation that we are all using nowadays. So this is the score. I took the number yesterday. So 26 million downloads on packages. And this covers basic needs for ORM, so Doctrine ORM implementation, and everyone is also reusing that to do caching like that. There are a few others implementation for caching with different interfaces. So Sonata project. I took the most downloaded one on packages, so here they are. As you can see, we have Sonata, Zen Framework, Illuminate, which is Laravel. So these are, have 1 million downloads because of, they are part of a framework that has some downloads also. And there's Stash, and Stash is the advanced feature provider for caching since a few months. So that's the other advanced caching system that people used to and still use to do advanced cache needs. So this is PSR6. PSR6 is really two interfaces, and this is the first interface. So this is about a cache item. And this is something special in PSR6. In PSR6, when you ask for something from the cache, you always get something back, even if there's nothing in the cache. You always get an item. And the item is an object that has this method there. So get key, you get the key you asked for. Get, the value that was there, is a hit. This is the special function, because if this returns false, it means the item was not found in the pool. So if it's true, it means the data that you read with get is the actual data that was stored in the backend. Why did they do that, and why did PSR6 do that? Because it wants to cover the case where you want to put null into the cache backend. So if you'd like to be sure that this null is not a cache miss, but it's actually a value, you need something else than null to decide. So this is how you can do that with PSR6, and having also an item is a way and an open door towards more advanced features, because you can imagine that this item and this method and this interface can be extended with another one which complements and adds more features. So with an item object, we could add more methods then later. Of course, the item can expire, so you know that you take something, you put something in the cache, and then you put it there for 1 hour. So we have expires after, so you can deal with that and say when the item should be removed from the cache. The next interface, and the only one I'm going to talk about, the other one are about exceptions, so error conditions. So this is the way to retrieve items from the cache. We have a has item to check if there's something there, get item and get items to get the item from the cache. So we delete items to remove them, save. You have the item, you put a new value there, you save, it's stored. Save deferred, commit, and clear to remove everything from this cache pool. So let's see how we can use that. You have a pool, let's say we created that before. So you get some item with a key, full key, you have the item back. Then on the item you call is hit. If it's not hit, then it means the cache is called. It means you have to compute the value. So let's compute the value. The compute value takes some time. At the end, you put the expiration date, 1 hour, and you save. By setting first the value with the item, and you save the item, and it's done. So now, if you want to get the value, you can call item get in the end, and the code before did the job to create the cache or take the value from the cache so that we have the fast path that goes out of the if condition. So the other way, another way, just another example on way to retrieve items. So this is the way to do multi-item fetch and multi-save committing. So let's say you want a bunch of values, so we put the keys, we have a list of keys, we ask the pool for all the keys, so we call get items, we get an array or release some iterator, and then we forward on that, so we have the key and we have the item. The item is the item object from PSR6, and we have the same logic there, saying, is this item coming from the cache? Yes or no? If no, let's compute it. Save deferred. Save deferred is not the same save as before. This one is just saying, let's put it in the pool for later, for writing later. So we do that in the loop. And at the end, on the last line of the slide, we commit. And commit is the actual call that does write and send the data and all the saved deferred items to the pool. So now we did things in bunch, in batch. Fetching several items at once is faster with some backends, and saving them in bunch is also faster. In batch is also faster with some backends. Yeah, okay. So some edge cases, things you maybe have to know, so that you can deal with PSR pool. So one is that if you want to get an item, so the item is this cache item interface object, there's only one way in PSR6 to do so, which is to get it from the pool. So you want to create, you cannot instantiate and say new cache item because there is no new cache item in the standard. Of course, you could do that with implementation, but with the standard, you can only get an item from the pool, which means reading something from the database. If the backend is a database, then you have the item. Another glitch or edge case is that keys have reserved characters. It means that you cannot use any string as a key, which means that in some situation you have to care about that and replace some special character so that they do not conflict with the cache recommendation. For error, PSR6 decided to return false whenever any backend error happened during saving, especially fetching also. So whenever a database connection is down, you will get false return values instead of any exception. And they did that, and PSR6 does that because if the cache is down, it means your application should be behaving just slower. It's not broken, it's just slower. So it's not a hard failure for your application. So that's why also PSR6 is not suited to store session data. Of course, if you look only at the interfaces, you say, okay, this is a way to get items from a pool, save items in a pool, let's put session data there. But you can't do that. If you do that, you will hit this return false as error handling, and it means it's not safe for session data. You don't want this behavior of having the session there or not, it depends, we don't care, we care for session. Some edge cases, so saving several items at once is not specifically atomic, it's not transactional. Fetching several items or even just one is not specifically lazy, which means you get the item. When is actually the request to the backend done? Is it when you get the item, or is it when you get the value on the item? Unspecified. So look at the implementation if you care. Usually you maybe should not care. And another edge case, which is that cache items are not interoperable, which means if you have one implementation, one pool implementation, you get an item from it. You have another one, another implementation. You cannot take the item and save that item, the same object, to another implementation because this other implementation doesn't know how to read the data inside the object. There is no getter for expiration, for example, in the PSR6. There is only a setter, expires at, expires after, but there is no get expire timestamp or get lifetime. There is no such thing, which means only implementation know how to read the actual value inside of the object. Okay, so implementation. There is a nice thing on packages, which are virtual packages. So we have this virtual package, PSR cache implementation. So look for that, and you will see several cache implementation. Some important one. So one is /PHP, another one is PHP cache, and of course, we have Symphony cache. So let's see into Symphony cache. Symphony waited for PSR6 before having any cache components. Symphony did not want to create, another interface and be without any standardization. So we waited for some standard, and then we implemented that. So the goal in 3.1 was not to be the most powerful caching library, it was just to be a strict PSR6 implementation. We take PSR6 and we do code to have something that works with the interface. Of course, it's in the Symfony code base, which means it has to follow the Symfony quality processes, test suite, code core team, reviews, double approval, and things like that. Backward compatibility promise, of course, you see, and it's just the bare minimum to be fast by default. So thank you, Tobias, for cache integration test about the quality processes, and this is something really great, and we'd like to have more generalized for the FIG. We have had a very successful collaboration with PHP Cache and Tobias on the test suite. So we share the same test suite, and we spotted together many edge cases because we had some different implementation of details, and yet the details can be tested. So now we have the contract, document, and having a test suite is really an amazing way to be sure that the implementation and the interpretation of the contract is actually the same for all implementations that share the test suite. So thank you again. So in 3.1, we have APCU adapter, which is a way to store data in APCU, which is a local shared memory pool that you can reuse across requests on a single PHP server. We have this array adapter, which is just some temporary array that stores the data and is destroyed at the end of the request, so it's not persistent. We have a file system adapter, of course, so the file system adapter is persistent, which means it's writing on the disk. It can be slow because I/O are always slow, yet it's the only default backend that we can rely on. We also have the Redis. So Redis is also, so this one is a server, so it's a remote service, and this one is storing things, and it's very useful for shared cache use cases. So if you have several, PHP servers, different ones, front end, and if they need to talk to the same server to have share a consistent state, then you can, deploy a Redis adapter and a Redis server to do that. We also have special adapters. So one is the abstract adapter to easily create new ones. We have the chain adapter so that you can chain several, so the APCU on top of Redis and the array on top of APCU, so that we can take the fastest when it's not empty and warm it up from the slowest, so that we always have the best condition. We have a Doctrine adapter, so and everyone knows that Doctrine cache is really leading the cache market, if you can use that word. So of course, we have a way to transform a Doctrine provider into a PSR6 adapter, and we also have this Doctrine provider at the end, which is a way to wire a PSR6 backend inside the Doctrine provider, so that you can use that into Doctrine also. We have a proxy adapter so that we can, and this one is a trick to fix this cache item incompatibility. It can wrap any PSR6, so it's PSR6 on top of PSR6. So the wrapped one is a PSR6 implementation that is not from Symfony, so that you can then, use all of them together without caring about cache items incompatibilities. Okay, so we love numbers, so here are some numbers. On a typical scenario, fetching items from the cache, checking if it's warm, and getting the value. So the code is different, of course, on Doctrine cache. It looks the same. We have Doctrine, and Doctrine is able on my setup, which doesn't mean anything really. We have 800 items per milliseconds. In PHP, one page is more than 1 millisecond. So in 1 millisecond, you are able to fetch 800 items with Doctrine, which is, I guess, enough for most use cases. We have PHP Cache. So PHP Cache is that 300 items per millisecond. We have stash PHP, 50. And we have Symfony at, in the between, 500 items per millisecond. This means almost nothing, yet it means we have Doctrine, PHP Cache, and Symfony in the same area. I think it doesn't matter really the difference at this level. We have Stash. Stash is slow. Sorry. Another use case. So this use case is getting several items from the cache at once. So this one asking 100,000 items at once. We get 700 items per millisecond with Doctrine. Same number with PHP Cache, same than before. With Symfony, it's faster. With Stash, it's also faster. So they are leveraging some, way to do that. Yet, I put APC on the slide because it really depends on the actual implementation. So I did another test, and this one is on Redis. So on Redis, if you do get multiple items with Doctrine Cache, there is an issue in the implementation, which means they are not using the multiple feature of Redis very well, which means they are much slower to get several items from the database. Okay, and on Symfony, we don't lose much performance using Redis because we use a way from Redis to get all the items at once, which is really fast. So really, it's again the same area. Check the implementation, check what you need. If you do care really about that kind of numbers, yet in most cases, these numbers are really enough for most, so you shouldn't care about that. That's my point, maybe not yours. Decide. Okay, now Symfony. We're at Symfony conference. Let's talk about configuration. That's how you're going to use PSR6, and that's it. That's maybe everything you should remember about that. So in Symfony 3.1 and in 3.2, you have this cache.app service. So you get that either from the container if you have it, or you inject that cache.app service into any service that needs a PSR6 compatible implementation to store things, and done. You can put items there. So you get, you save, and done. No configuration, it works. But we need power, and we are power users. So let's do things for ourselves. Let's say now you have this cache app thing, and this one is storing keys from any part of the application, which is not good because you'd like and you'd prefer to have several pools, one per subsystem in your application, so that keys don't collide, and you don't manage yourself prefixing keys so that they don't collide and things like that. So you can do that with a Symfony configuration, and that's only what you need to do. You say framework in config.yaml file, you say framework cache pools, and then you list pools, and the string there is the name of a service, so you list services there. So let's say myapp.cache.geodata if you need a pool for geodatas, and then you can access that with @myapp-cache geodata in service YAML configuration so that you can inject that pool and have it separated from other pools. So of course, you can add more. By default, cache pools are private. The services are not public. You can't get them when you have the object container. So what you need to do to get them is that you say public true and done. You can do container get myapp-cache geodata and get the actual implementation, the actual cache pool, so that you can get items and save items there. Okay, what's the default? Because we are talking about logic pool right now. What's the default? I need to care, and I care about the actual backend. So you can configure the backend, and Symfony ships with several backends ready and pre-configured. So one is Redis, so now you can just add adapter, cache.adapter.redis, and this is an abstract service that you can use, and with this line, you're saying that this cache pool, this geodata cache pool, is going to use the Redis adapter to store the items. Done. You're storing things on Redis. Okay. But if you were to have several cache pools, it's great in that kind of situation to be able to reconfigure and say, okay, all my pools should be stored on Redis. This is the way to do it. You say app cache.adapter.redis. It means that the adapter of all your pools are going to use Redis. So you can mix things, of course, and have one pool on Redis, another one on database. the default one being something configured like that, and done. So, cache.app is a service that exists, and it's the way to store model sourced items, domain sourced items, so items that you manage and which are some kind of related to the content of your application. So it defaults to the file system because we don't have anything else working by default. Of course, you should change that and use Redis to store things or any shared backend, really. There is another service, in fact, in Symfony, which is cache.system. And cache.system is something you can use also for you. And this one should store only code-sourced items, which means the result of parsing annotation, template, reading things you create from the source itself. So it means each front end, each PHP server can have its own copy of the generated data, and you don't need a shared state because each front end is able to generate the artifact and feed the backend there. So by default, this uses APCU. And if you don't have APCU, it uses the file system. And it does that in chain. I'm going to talk a bit about that later. Okay, so now let's say you'd like to use this nice geocoder from William. Where's William? So geocoder is something really nice, but it has to, it can use only a Doctrine cache thing interface to store the cache data from the geocoder. So the way to do that and the way to mix both systems together is to say, okay, I'm creating now some proxy service, and this proxy service, let's call it geocoder Doctrine cache. We are just saying in our service YAML file, it's an instance of our Doctrine provider, and we inject there the geodata cache pool, PSR6 one. So this way, this new service, the geocoder Doctrine cache, is the service you should inject into the geocoder service itself so that it can store items through the Doctrine provider into the backends you configured previously. Okay, next topic. Symfony Cache 3.2. In Symfony 3.2, we decided to go beyond PSR6, so to add more features and also to add more PSR6 related features. So one missing feature was this command line command. So bin console cache pool clear, and then you give the name of a cache pool, and you clear the cache. It was really missing. We missed that. And now what you can do when you are deploying, building your application, deploying mostly, you can call this command and say, okay, this pool needs to be cleared because, okay, the data there is not valid anymore. Let's clear it. So you should do add these kind of things into your deployment scripts. We have new adapters. So we have the PDO adapter. PDO works also for Doctrine debug. So of course, it's for storing things into the SQL database. We have this PHP array adapter. And this one is a trick that is enabled by PHP 7. And if you don't know that, you should read the Blackfire blog. We have an article about that. In PHP 7, there's a wonderful thing, which is that static arrays, so a static array is an array that doesn't contain any variable, any object. It just strings and numbers and scalars. So a static array in PHP 7 is stored in shared memory. There is one copy of this array in OPCache, and all the requests that are reusing this exact same array won't need any copy from the shared memory. PHP 7 is able to use the shared memory and read from it directly, which means this is amazing. You can put there a big array, and it doesn't cost anything. It's free. So this is a way to leverage that, and we put a PSR6 interface on top of it, so you can access this array as a PSR6 store, and yet it's something, the fastest adapter you can imagine in PHP 7. So PHP array is one big array for all the cache items. Of course, it's read-only. And we also have the PHP file adapter, which creates many small arrays one per item there, so that you can, have different strategies. Either you're able to generate this big array before, and you should use that, or you can't, and then you should use PHP file adapter. And the last one is the null adapter. So the null adapter doesn't store anything. It just returns cache misses. So you can use that in your test. If you need a null object, this is the null object of the PSR6 and Symfony Cache system. And there's a pro tip. If you really need to create an item, a cache item from Symfony, you can create one from the null adapter. This will return an instance of Symfony cache item, and you can use that into PDO adapter, APCU adapter, if you need to not read APCU or the database before to get the item. So I don't know if that's useful, just sharing. Okay, so the cache.system I told you about is a service that is there by default, and it's configured to use PHP-7 arrays by default. So all system caches in Symfony use PHP-7 arrays if you happen to use a PHP-7, of course. It's able to detect APCU also automatically, which means you don't have to configure things anymore about APCU for Symfony cache-related things. It just works. And we use the file system by default. Of course, if you don't have PHP-7 or APCU, we use file as storage. That's the only one we can use then. We do offline cache warm-ups for all the cache system derived pools, which are cache.validator, cache.serializer, and cache.annotations right now. So these are warmed up. So we create a big PHP array on PHP-7 for annotation, for example. We are able to scan for all the annotations in a code base, and we create a big PHP array with all the annotation, and on PHP-7 it's free, so nice. And there is something else which is not there, APCU. So APCU is tricky because APCU has a shared pool for your FPM server, and there is a different shared memory pool for console command. And from the console command, you can access the shared pool of your FPM process. So there is something difficult there, and you cannot clear an APCU cache FPM1 from the console. That's not possible. You don't have access to it. So now we figured out a way to fix that in Symfony, which is to create a prefix and generate a new prefix whenever you rebuild the container, so that by fact you won't access anymore the old data, and when you deploy your application, you're going to use the new APCU key subset. And we are able to warm up APCU also, because we have this chain of APCU on top of the file system. So we create the file system pool, and we use APCU on top, so that APCU is warmed up from the file system, not from computation. Okay, and last feature of Symfony 3.2 is tax-based invalidation. So let's say you have items everywhere, and you want to remove and to invalidate some cache data because it's not valid anymore. With tax-based invalidation, you can invalidate all related things. So this is an example. Let's say we have products and reviews for products. So we store reviews, of course, in the cache. So we have an item there for review ID. We get that item. It's the cache item. So we set the value of the review, and we add tags on it. So let's say we have, in this case, 3 tags. So reviews, product, and the number of the product. So we are related, saying this thing is a review, this thing is also related to a product, and also specifically to product ID things. So we save that. And what we can do later, when something happens on the product, on reviews, is that we can invalidate all the items that have this tag or any of these tags on them. So let's say something happened on product ID, you just invalidate that tag, and all the reviews for that product are invalidated. I mean, all the cache items for the reviews. Or if you happen to want to, drop all the reviews and all the cached items for reviews, just do the second line. You invalidate the reviews tag and all the items are gone. Same for products. And if you'd like to do both at once, just invalidate all the cached items for products and reviews, done. And of course, the end result is that if you happen to get the item after calling invalidate tags, you'll get a miss. Nice. Last topic on the tags-based invalidation, you can chain and have different storage for items, so the data you put in the cache, and tags, so that you can have, let's say in this example, we have a local storage, file system storage for the data, so you can have data duplicated on every front, each one with its own copy of the cache system and cache data. And if you'd like to synchronize all the item and know when on one front when data is invalidated, all the front and the other PHP servers should be able to invalidate that same data. You can do that by chaining, in this example, the file system with a Redis adapter, Redis being the shared state of the cache. So you invalidate, Redis changes its state, and you get fresh items on all servers at once. Almost done. So, what's next? In Symfony 3.3, we're thinking about a way to serve stale items while refreshing the cache, so that you never end up into a situation where your front-end server is regenerating the cache, because it means one of your users is experiencing a slowdown, because this one is waiting for the cache to be actually regenerated. So if there is only one person, maybe you'll say it's okay, but if when the expiry timestamp is over, all your user experience a slowdown because all the front are regenerating the same item at the same moment, it means there's something wrong. So we are thinking about adding something to fix that, so that only either one user is experiencing that, or maybe your better strategy would be to say, oh, this one is going to expire, let's put a message in a queue so that a worker can then in the background regenerate the cache, so that then no cache miss ever happen on the front end. Desynchronized cache misses, so this is a way to have a bit, several seconds of difference in the expiry timestamps, so that if you happen to put things in production with an empty cache, it means you are going to regenerate most of the content at the same second, if this happens to be fast enough, and they are going to expire also all at the same second, 1 hour, 1 day, 1 week later, which means at this very second your cache is empty again. So by just having some seconds of difference in the end of the expiry period, it means you're able to average the cache misses on this period. User experience, so it would be great to have a profiler panel in the web toolbar. We're missing one right now. And last item we're thinking about right now is PSR-16, which is called Simple Cache, and PSR-16 is a way to store cache values in something that has no cache items. So it's a cache item-free version of PSR-6. So you could use either, depends on your use case and your preference. And this is, something we're talking right now, and we're going to talk, I guess, during the conference with Jordi and a few others. So this should happen, and since P.3 is in 6 months, I hope this will be ready in 6 months. Thank you very much.